Hi, I'm Jain and will represent to you the work that our group has done for the final project. As you can see, we are doing face mask detection with the connection of the platform provided by the Advantech company. The logo is designed by one of our members. Not to forget, our team member's name is listed here. The content of the video includes motivation, where the purpose of this work will be explained, the problem statement, which the challenges for the task. Next, the methodology of the strategy we have used and the demonstration of our application. Lastly, a conclusion to conclude the things mentioned above. First, the motivation. The use of a face mask is recommended as part of personal protective equipment since the COVID-19 outbreak. Especially in public, it could be help to prevent the spread of disease. However, it is important only if the face mask is properly worn, where it is covering both the nose and the mouth. Here comes our problem statement. As a human being, it is easy to detect a person without wearing a face mask. What if there are a lot of people? It requires a lot of manpower to do things. Hence, this is where artificial intelligence comes in. However, a face mask can be customized to different colors and styles. This will be a challenge for the machine to learn. On the other hand, how can we stream our video lively to the cloud computing, or to be specifically the platform provided? Therefore, the following part is the strategy we have used. It is divided into three main parts, where face mask detection, video streaming, and data visualization. For face mask detection, we refer to the paper published on ACM 2021 entitled Mask or Non-Mask Robust Face Mask Detector via Triplet Consistency Representation Learning. It is a small model with the architecture of ResNet and Convolution Block Attention Module. Also, it is an anchor-free detector with triplet consistency representation learning. There are several loss functions used in this paper, which are central loss, triplet loss, and consistency loss. For central loss, it is composed of three parts. The first, LPix, is used to predict the key points, and it's a pixel-wise logistic regression. The second, LLof, is the offset loss function to solve the errors due to the discretization. And the third, LS, is used to compute the loss for the bounding box size. Next, the triplet loss that enforces the distance between a pair of samples with the same label is smaller than that between a pair of samples with different labels. Lastly, the consistency loss. It calculates the loss between the predicted heat map of the original image and the predicted heat map of the horizontally flipped image. LCon-C uses Jensen-Shannon divergence to measure the difference between two heat maps, while LCon-L is to match the localization results of two heat maps. Next section will be introduced by Emerson.
Hi, this is Emerson. I'm going to share the part of the internet application of this project. In cloud computing, to detect whether a face is wearing a mask, we have to stream the local camera to the cloud. So the question is, how to stream a video to the dashboard? To solve this problem, we built a web server with a homepage that supplies some useful APIs and streaming sources, but one can only visit the website on local area network. In order to make the server accessible from the internet, we apply the DDNS for the server, so anyone can access the website and service anywhere, as long as one is connected to the internet. Since the dashboard on the WISE-PaaS platform only allows the input streaming video with a trusted SSL certificate, we also managed to create an SSL protection free of charge.
Thanks Emerson for the explanation on video streaming. Let's get it on. For data visualization, we have used the dashboard service given to show our video and other data information. We designed the dashboard outlook and made a line notification when it detects that someone is not wearing a face mask. The following part is about the demonstration of our work. We will first go through how the web server works and then perform a live video streaming demonstration.
Let's take a look about our homepage. As you can see, there's a HTTPS, and which got a private SSL certificate, and there's a DDNS, which can lead everyone in anywhere as long as you got a connection with the internet. You can visit this website. And what we got is here. We got a video application, a streaming. You can this is a video now streaming from the Raspberry Pi, and you can make the face detection work on this the streaming video. But now I think the Raspberry Pi doesn't think that there's any face on this video now. Oh, and you can take a picture for this video. And also there's a dummy source will stream a GIF on the website. And also you can make the face detection on this GIF too. Yeah, and you can as well take a photo. In order to stream the local video on the internet, we got a new streamer to help us. And there's a home page for the optional function. And there's a streaming video. You can see this is literally the webcam now streaming my local video to the internet. Let's put it back. And also, there's a function for taking a picture. And there's a connection without streaming. It's useful for develop the state JSON API. Let's take a look for the API. Yeah, I got 3 dummy client source, and you can see there's 3 clients now, and it tells you that encoder is M2M video, which means the Raspberry Pi is now using GPU for encoding the streaming video, and it tells you resolution about the streaming video. Basically, it's showing the detailed information for the streaming server. Now let's take a look about the JSON API. First is the CPU status. You can see there are some information about the CPU on the Raspberry Pi. And second is streaming information. It's the same as this state, and the only difference is this link offers the SSL certificate, which will be allowed from WISE-PaaS platform. And third, this is a CASA plug, which is a smart power strip, and it will tell you about the current and voltage and the power consumption and the total power consumption, etc. And it will be streamed onto the dashboard. Also, there's a restreamer, which is like a middleware, which can be posted. You can post your video from on this site, and the server will transport your video to the internet. And like this is a game of life. This is a kind of algorithm, and it is now working from the Raspberry Pi. This is our debugging tools. There are some functions, and first is threading debug. And as you can see, the server running on the Raspberry Pi is now showing the same information with the web page. And if we stop the web page, the server is still going, and we can see 80 seconds and 16 seconds. We can know that there are 2 seconds of delay, and it can tell you the latency of the server and client. And this is a function that will tell you your router and IP. And this is a error handler. You can type anything you want, and if it is not exit, it will lead you to this page. Yeah, and last, our server. Oh, yeah, and let's disclaimer. In case that we have no responsibility to anyone. Yeah. So the link of this server will be under the. I think it will be attached to the document. Yeah, so if you got interested, yeah, have fun.
So we will start our demonstration video right now, and as you can see, the video is captured real time, and it will be shown on the dashboard of WISE-PaaS. And the other side is some other information. that provide with our state right now, where the device and the power. And if someone is without a mask, it will show an alert and the live notification us. And that's all for our demonstration video. Thank you.
This is how our application works, and let's move on to the conclusion. Several points to conclude our work. First, we reproduce the work of the paper mentioned. Next, we have built a web server to stream the video. Lastly, we make our data easier to understand using the dashboard. This is the end of the video. Thanks for listening.